Before we get too far into Chapter 10, I think it'll be very helpful to get a little table going of some of the powers. I have a little bit bigger one that we'll do a little bit later in this chapter. That'll help you out. And we did 2, 3s, and 5s. We obviously didn't, well, obvious to me that we didn't do 4 because you can get down to 2 if you've got a 4, right? So 2 to the first. 2 followed by 4 followed by 8. Very good. Some people have told me 6 in the past. Remember, it's 2 times 2 times 2, not 2 times 3. Big difference, right? 2 to the fourth means 2 times 2 times 2 times 2. You notice all you're really doing is multiplying by 2 again. Okay, so 16 followed by, getting a little bit harder, 32 followed by 64, right? Now 3 is quite obviously 3, 9, a little bit harder, 7 getting a little bit bigger, very good, 81, and 900, no, 243. You notice that I didn't go quite as far as exponents as I did before because obviously 3 to the 6th is considerably bigger than 2 to the 6th, correct? Because the base is so much bigger. And 5 to the 1, I hope you know that one. 25, and this one, as you notice, gets big in a real hurry. And imagine if we would have done 5 to the 6th, how large that would have been compared to 2 to the 6th. Even though the exponents are the same, they would have been different. Now there's one particular power I didn't do on any of them. 0. Because what is, for example, 2 to the 0 would fit here, right? Which is 1. 3 to the 0 is 1. 5 to the 0 is 1. 1 million to the 0 power is 1. Okay, so that's why I didn't really do the 0 power, but it's good to know that anything to the 0 power will be just 1. Okay? They kind of have to define it that way or lots of other things go haywire. All right? So what I actually want you to do in these problems is manipulate the base. I don't want you necessarily to solve. I don't want you to necessarily get too into it. It will, I think I've made these fairly nice that it will just come down to a power. But you do have to remember a lot of stuff from Algebra 2, specifically Chapter 5. The one that took, well, when I taught it, took about 2 months to get through. Okay, where we split it into 3 parts because it was so big. This one, what I want you to do, there's lots of ways to do it, but what I want you to do, and evaluate means get a value. I want you to, as it says here, manipulate the base. Well, what's the base here? The 16 or the 1/4 that's up in the exponent? 16 is the base. Is 16 on here anywhere? Yeah, right there, right? 2 to the 4th. So am I allowed to replace the 16 with 2 to the 4th? If it's equivalent, can you replace it? Sure. But realize all I replaced was the 16, right? Is the 1/4 power still technically there? Yeah. Now what you need to remember is that this is just one base that is taken to a power and taken to another power. When it's a power to a power, what do you do with exponents? You multiply. So you write down your base of 2, and you multiply your exponents. And what is 4 times 1/4? Is 1, right? And what is 2 to the 1st? Well, it's on your other page, but I hope you don't have to look back. It's 2, right? Now, very quickly, I would like to review another way you probably or possibly could have done this problem, because I do want to review what a fraction in the exponent actually means. Does anybody in here believe they remember what a fraction in the exponent actually means? Yeah. Yeah, it's a radical of some kind, right? So if I wanted to rewrite it, there's a radical. That's what that fraction means. And the top number goes there, and the bottom number goes there, or the numerator goes right there, and the denominator goes out there. And where's the 16 go? Well, right there. That's the equivalent. It's the same thing. And you're going to learn in calculus that being able to take it from this radical version to the exponent version is going to save you a ton of time. And what you could do then is write it like that, correct? 2 to the 16 is still 2 to the 4th, isn't it? And what'd you learn in Algebra 2? Paucify. So hey, did we get 2 both ways? Yes. Which of the 2 ways do I want you to do it for right now? The green way or the blue way? Green for right now. Okay? I don't want you to just take out a calculator and type in 16 to the 1/4 power, because chances are you'll type it in wrong and it'll give you some weird answer. Okay? So please just avoid that for now. Well, now what's that negative dealing with? We talked about that on Friday on some of the problems, what the negative meant. It meant the base of 8 is, at least the way I taught it, means it's unhappy, right? And we want to make it happy. So we put the 8 in the denominator. Because right now it's in the numerator, and it doesn't want to be there. And so something's got to hold the place of the numerator until we choose something that won't change the problem, and we choose 1. Okay? Now, what we're going to do is what we're supposed to do, which is manipulate the base. Well, is 8 anywhere on your little table up above? Now, where is it at? Next to which one? 2 to the third, right? So 8 gets replaced with 2 to the third, and the 1/3 power is still there. I hope you realize that. And what do you do when it's a power to a power? Multiply. So the 1's still on top, right? Nothing happened to that. So there's still a 2 here. When you multiply those, you get, once again, coincidentally, 1. It's as if I made these problems to work out this way. 1/2. Okay. Any questions so far? No? All right. Uh-oh. 64. Is that on your chart somewhere? Where was it? 2 to the 6th, which is to the 2/3. Please realize if you get somebody to help you on these problems, these are not the only way to do them. It just happens to be the quickest for what I want. So your base is 2. What do you do with those? Your exponent is not 6 2/3. All right? You got to multiply your powers, right? So what is really 6 times 2/3? Right? Yeah, because it'd be 1 and 2, right? It'd be 4. So it's 2 to the 4th, right? If I multiply what's in the circle there, or oval, it becomes 4. I'm actually okay leaving it that way, but 2 to the 4th is up in your little table, right? So you can just write 16 if you wanted to, right? And he didn't use a calculator. Well, at least I hope he didn't. I didn't hear any keys going, but either answer is fine. All right? I don't really care. What's different about this one? Yes. Yeah, it's already a fraction, right? So there's a fractional exponent in a fraction. Very bizarre. Yeah, at least everything's happy, right? Everything's at least where it wants to be. Well, I'm looking at the 16 and the 4, and I'm telling you to manipulate bases, right? Well, are they both at the same like area in your table? They are. 16 and 4 are both under which one? 2. So what is 16? It's 2 to the 4th, right? And this is 2 squared, right? 4 is, which is also, though, yet to the 3/2 power. Wow, that's just a lot of 2's. And I kind of like all those 2's in there because you got to figure out, well, how do I deal with them? That'd be great if they all cancel, but they don't. Where I would look right here is to deal with that. So let's leave the 2 to the 4th on top. 2 to the what? Because it's 2, this 2 right there, times 3/2. What do I get? 3. Well, now what? This hasn't happened yet. This is me seeing if you remember how to do this. There's a long way and there's a short way. The long way is to do this. Okay, isn't that really what it means? And a bunch cancel off, right? This is kind of the longer way. Cancel, cancel, cancel. Oh. Or what you can do is once the base is the same, write it down and do what with exponents? Subtract, right? When it's division, you subtract. You get the same answer. So when you multiply with several bases, you add. When you divide, you subtract. Yes? Yeah, I'd be fine with that. The question was, is it okay on that one if you just do the bottom with the base and kind of get down that it's 2 to the 3rd, you mean, and then write it as an 8? That's fine. Yeah. I just wanted to show you the subtraction so that you remembered that. Yeah, that would be fine. Because you still manipulated the base, so you still used that idea. Okay. say get the base as small as possible. That's what I mean when I tell you to simplify. Okay? So 12, well, let's figure out what we got to do first here. It's a power to a power again, right? So let's multiply that. Can you take the square root of 5 times the square root of 2? Can you do that? Yeah, it's the square root of 10. Would that be sufficient based on my directions? No. That is not as small as that base can get. Because where does 23 appear on your little table up above? 3 to the third, yep. So this gets replaced with 3 to the third, which is to the square root of 10 power. Any questions where 3 to the third came from? What am I going to do with these? Well, now, here's the trick. Does that become 3 square root of 10 or square root of 30? 3 square root of 10. Very good. Now, if it was a square root of 3 times the square root of 10, that's when you get square root of 30. Any questions so far? Again, there's lots of ways to do these problems. Yeah, probably the quickest way to do this one is to get the base as small as you can first. Can anything be done to the 4? It can be written as 2 squared, which is also to the square root of 2 power, times this one over here, 2 squared, which is also to the 2 square root of 2 power. You thought there were a lot of 2's in the other problem. Any questions where any of the 2's came from? You may have to come up here and point at it if you do, but no. So this really turns into, because you got to multiply these, right? Is it the square root of 4 then, or how's that work out? Well, no, it's 2 square root of 2 times 2 to the, now how do you do that one? There's a 2 here times that 2 times that square root of 2. Can you even multiply any of them? Yeah. Yep, 4 square root of 2. Very good. Any questions how I've gotten to where I'm at in that problem so far? Got it? Now, in that last division problem we had, once we got the base, see how this is multiplying different bases, or 2 separate bases? Once you get them the same, write it down. What do you do with exponents at this point? Up here, when it was a power to a power, I multiplied, right? So now what do I do when they're separate bases, or separate exponents like that? You add them. What you need to decide now is, can I actually add them or not? Oh, I think I heard somebody say 6 square root of 2. Is that how we can add them? Yeah, the radicals have to be the same, though, and they are. What do you do with the 2 as a base? Do I mess with that? No. 2, and then these added together is actually 6 square root of 2. And that's fine. You can leave it like that. Questions so far? I hope you can agree by now this is a lot of chapter 5 from Algebra 2. Manipulate what you got there. What can you do algebraically and what can't you? Well, here's a division problem. Well, what did I tell you to do on number 6? How did I tell you to start it? To get the base as small as you can to start with and go from there. Are these bases as small as they can be? No, because 64 can become 2 to the 6. Are you catching on that that square root just kind of tags along like that? You're starting to catch on that's what happens every time? All right. So here's your 2 to the 6 for that, divided by that. So on problem number 14, we did something that happened similar, right? The base was the same, but there were 2 bases, but it's the same. And what are you allowed to do at that point? When you're simplifying, you're allowed to write it down, right? And then, yeah, you can go ahead and subtract. So it'd be 6 square root of 7 minus 1 square root of 7, right? That's really what it would say. And is that something you can actually subtract? Yeah. So it's 2. And then 6 minus 1 is 5. What I would like you to do for a second, number 8, is just try and get the base as small as you can. Just do that first on your own right now. Don't worry about the rest of it. Just get it as small as you can right now. What base did you get to? Pardon the pun. 2. So, and you're probably catching on by now, like I said, this is 2 to the 3rd, right? And that square root of 6 just kind of tags along, right? Times 2 to the 2nd and square root of 54. Any disagreements with how I started the problem? But I have a base the same, right? There's 2 of them. They're the same. Write it down. Again, that write it down thing is when you're simplifying. So I've got 3 square root of 6 plus 2 square root of 54. Right? You add exponents. How come that's not the answer I have written down on my sheet of notes over there? Yes. Yeah, 54 can be broken down. It's as if I, again, expect you to remember stuff from other classes. Yes. Oh, you have it broken down? Okay, let's break it down over here. Just the square root of 54. Yeah, square root of 9. Square root of 6, agreed? 9 times 6 is 54. Why would we choose 9 and 6? It's a great choice, by the way. Yeah. Yeah, it can't be, and we know the square root of 9 is 3. Okay, so now what does that mean? Here's definitely where I had one professor in college that would get so excited about this problem he would have gotten lost and forgot what he was doing and said that 3 square root of 6 was the answer to the problem. But keep in mind that there's this 2 is still here, right? This is still there, right? That 2 is technically still there. And this has just been rewritten as that. Agreed? So that can go here if you want. I know I'm taking more steps than some of you are using, but I don't want you to get confused as to where this stuff is going and all that stuff. And I'm going to move it up here now. Okay. So we got this 2, 3 square root of 6, plus what? Really? What's that turn into? 6 square root of 6. Very good. Well, now, that's still not the answer. We've done a great job of that, but that's still not the answer I've written down over there. Because you can actually add them now. Could I add here? No, you couldn't actually add because the radicals were different. Now the radicals are the same, square root of 6, square root of 6. So now you can actually add, and I feel sorry for whoever watches this video, but anyway, so it's 2, and we've got 9 square root of 6. Yeah, I kind of did almost make a circle out of that. What happens if you, now everybody understand that's the answer to this one? What happens if you get here and you have like a 5 in there instead? Yeah, then that's the answer. Yeah, you don't just go and start adding them because you think it's always supposed to work out perfect. It doesn't. If that one has a square root of 5 there and that has a square root of 6, don't add those. You're not allowed. But luckily we had 6. Okay? All right. What's that say to do? Take that times it's L. Wonderful. Well, hey, it's almost problem number 10 then. What's the difference between 9, the way I wrote it in red, and 10, what's over there? Yeah, 1's minus over there, right? So believe it or not, in 10, that's still that difference 2 squares setup. Even though it looks horrible, but it still is. But for number 9, it's not. Okay? All right, so let's figure out what we got to do here. Well, we got to take that times that. Eesh. Well, x times x, it's the same base though, right? So write it down. What should I do with those exponents then? Add them. Can you actually take the square root of 2 plus the square root of 2? What is it? No. 2 square root of 2. Because really what it would look like is that, right? Adding, so it'd be 2 square root of 2. Now you take x to the square root of 2 power times 3. Yeah, so plus, well, 3 of those. So we'll color code and do the other one in blue. So we'll take 3 times that. Well, didn't we just do that? So it's the same thing. And the only ones I have yet to multiply, which end up being easier in this one, right, is 9. So of course this is where we put the squiggle in and do all that stuff, right? No, I can tell you what the answer will be. It'll be x to the square root of 2 plus 3 and x to the square root of 2 plus 3 if we put the squiggle in. We'll go right back to where we started. Okay? If we put the squiggle in, we would have gone right back to where we started. Yeah, we combine these things right there. So that we didn't do anything there, right? Plus, well, we have 3 of them here, and we got 3 more of them over there, and so we have 6 of them. And then plus 9, just the 9. Can I combine the first 2 terms? The variable doesn't have the same exponents, you can't. Okay, so you can't add them. That's it. Now what if this 2 wasn't there? If that 2 was gone, then you would be able to, right? You'd be able to add those and have 7 of them. But that's there, so you can't. I mean this one here? Yeah, there's like an understood 1 there, yeah. No, because either the bases and the exponents have to match, and we're adding, not multiplying. So if I had x2 square root of 2 times 6x to the square root of 2, then those can be combined because it's multiplying. But we're adding. Different rules, okay? Variables have to match. Great question. I don't think anybody's ever asked that one. Now, based on your knowledge of difference of 2 squares, should this foiling be easier or harder? Why? The 2 middle better. Yeah, O and I of FOIL better cancel if I did it right. Well, didn't we just do that? What do we get over here? We got x to the 2 square root of 2, right? Minus 3 of those. Plus 3 of those. Now be careful. Here's where most people get going a little too fast and get it wrong. It's a 9. That is negative. You told me before we started that those 2 should go away, do they? Yes, they do. They cancel. Yeah, and so x to the 2 square root of 2 minus 9. I know that doesn't look like something you would try and factor that way, but you could. Right? So any questions on this sheet of notes? This is day 1 of 10-1. Well, if you're thinking that's easy, this won't be too difficult of a chapter, I don't think. Because I don't think this was necessarily all that easy. So.